Okay, so this is lessons on the derivative of trig functions. The derivative of sine x is cos x. The derivative of cos x is actually negative sine x. And the derivative of tan x is 1 over cos squared x. If you have a function, instead of just x, you have some sort of other function in brackets, then you need to multiply in front by the derivative of those brackets. And that's pretty standard for all three, sine, cos, and tan. Okay, so I'll do a couple of examples. Y equals sine 5x. Here I need to take the derivative, so that we're following the derivative of sine x, but I have to take the derivative of what's inside the brackets and multiply in front. So my derivative is going to become, derivative of the brackets is 5, and derivative of sine is cos, so it becomes cos, and then my angle does not change, so it's just 5x. So it's 5 cos 5x. Remember, what's inside the brackets is technically your angle, that does not change. Okay, here I have cos. My angle is 2x plus 1, so I got to take the derivative of the angle, which is just going to be 2. Derivative of cos becomes negative sine, so it becomes negative 2 sine, and then my angle does not change. And that's the derivative. The derivative of tan, my angle here is 4x squared, so the derivative becomes, and it's going to follow the 1 over cos squared, but I need to take the derivative of the angle, so it's going to become 8x over cos squared, and then the angle stays the same. Okay? Here's your function. Here's your equations again. Sine becomes cos, cos becomes negative sine, tan becomes 1 over cos squared. And then in the examples where you have an angle, it's not just x. You have to take the derivative of the angle and multiply it each time in front. Okay? So here's some other examples. This one is involving trig that's in a product rule. So I have to follow the product rule because I have two different functions multiplied together. So my derivative is going to go the derivative of the first, which is just cos x, times the original of the second. And it goes plus, and then it goes the original of the first, derivative of the second. Okay? And then I can multiply these together. Cos x times cos x is actually cos squared x. And I want to have sine x times negative sine x, which is negative sine squared x. Okay, you may be asked to simplify it a little bit further using trig identities. This example right here, I want to find the derivative. This is actually going to be the chain rule because the square root is actually to the exponent of 1/2. So I need to do the derivative. I'm going to bring my exponent down, right at the inside, reduce the exponent by 1, and that's going to be the derivative of the inside, which is going to be following my trig formulas. So I have to take the derivative of the angle, sine becomes cos, and then the angle does not change. Okay, so that is following the chain rule. Then you might be able to simplify a little bit. I can actually multiply the 1/2 by the 3, so that's going to give me 3 over 2. And then I can have my sine 3x, cos 3x. Again, you might be asked to simplify a little bit. Oh, that's to the negative 1/2. A little bit further. So your derivative in this case will become, if I want to get rid of that negative exponent, I have to take it down to the denominator. 3 cos 3x over 2 square root of sine 3x. So the negative 1/2 becomes 1 over the positive square root. Okay, but you may or may not be asked to do that, depending on the question. Okay, so some derivative of trig functions. Sine becomes cos, cos becomes negative sine, tan becomes 1 over cos squared. If your angle is some sort of function itself, you have to take the derivative of that angle and multiply it in front. Thank you very much.